At one point of our lifetime, we've experienced something called the natural frequency without even suspecting it. As a kid, we all wanted to go as high as possible on a swing, but in order to do this, we needed a little help from our parents to do so. In order to be able to achieve the maximum height, our parents needed to push us at a particular rate at a very particular moment in order to achieve the maximum height as possible. If our parents pushed us at the moment that was not that particular moment that we were seeking, we would not be able to continuously climb to our desired apex.
A swing could be modeled as a simple harmonic system, in which the distance moved is proportional to the force applied. As the swing moves back and forth, its repetitive motion depicts simple harmonic characteristics. The harmony of the swing comes from the elapsed time in between successive intervals by which our parents would push us. This harmony could be quantified as the cycles per second, also known as the frequency. For any repetitive motion, there is a natural frequency in which the optimal amplitude can be achieved. As the frequency of the pushes from our parents got closer to that of the natural frequency of the swing, we'd begin to move higher and faster. This basic idea can also be applied more aptly to a mass on a spring. However, in fact, a mass on a spring is simple harmonic motion. As it can be noted in the initial part of the experiment, when my finger strikes the mass on the spring at a frequency that deviates from that of the natural frequency, we are unable to achieve much of an amplitude. When the force applied by my finger is synchronized with that of the natural frequency, one can see that a much greater amplitude is evident.
Elaborating on this concept, theoretically, if we run current through the coils of the wire, we should be able to see an attractive force between the coils of the wire, which lifts the mass on the spring mass system.
This phenomenon can be attributed to the coupled properties of electricity and magnetism. As the current is sent through the spring, there is a magnetic field and a magnetic force that is created. In retrospect of the concept of natural frequency, if current is periodically introduced at a frequency similar to that of the natural frequency, we should be able to move the spring until we achieve a maximum amplitude.